Good evening. Start with the class. It's a new chapter, that is motion in a plane. The previous one was in a straight line. This is motion in a plane. Straight line means normal, like in one direction only. But in a plane means it could go in this as well as this way. Okay, so whenever you want to understand a plane, imagine like this at the corner of your walls, okay, on the floor or even at the ceiling. If you watch, this is one line. Okay, this will be like your ground. Okay, the floor, this will be your wall, and this will be your wall. So this wall is nothing but a plane. Again, this wall is another plane. Even your floor is another plane. Okay, the plane is nothing but a like a paper or piece of paper, and line is like a normal straight line. So in this chapter, it is mostly all about vectors. The basic intro I had given to you all about vectors in the previous straight line chapter. Now we'll study that in detail. Okay, so this is, so what is a vector? Vector, I told you, will always have magnitude and direction. Scalar quantity always have magnitude only its value. But over here, vectors, you have to specify the direction. Like how we said, the scalar, and suppose this is vector. Here it was what? Like example we had taken was, this was distance and this was displacement. Distance is a scalar quantity. We don't want which direction it is going. But displacement, we need to know from where it went and where it came back also. So that is called as a displacement. So it needs a direction. An example of one more was, this was speed, normal distance upon time, and velocity was vector quantity, displacement upon time. Then one more, suppose if you want work done, any work you are doing, okay, that is like some kind of energy you're spending on that. Okay, that will not have any direction not needed. But suppose if you have force, if you're applying a force, definitely it matters in which direction you want to apply a force. If you want to move a table, okay, over here, you want to push the table over here, definitely you cannot apply the force this side and try to move here. So if you want to move anything from here to here, the direction of the force also matters. If you want to push, you have to push it in this direction, or at least pull in this direction. The force is a vector quantity. Whichever needs the direction also are called as the vector quantity. How do we represent a vector? Right, what is representation? Always represented by an arrow, I told you. So this arrow will always have a tail. This part is called as a tail. This part is always called as the head. Whichever has the arrow is the head part. Now suppose if I say E is a vector, then how do I represent? Like this. Sometimes they normally put it as bar also. They don't put this arrow, but mostly in this chapter we'll use this. In mathematics and all not required. Normally we use this, but in physics now, since we are learning the direction specifically, so we'll use the head and the tail part. Okay, we'll specify this arrow. Now practically what happens is, if the this magnitude, if the value of the vector is very big, no, we'll have to put actually big arrow on the letter, but on the paper you cannot put that. Okay, it becomes difficult while writing any equations and all along with the big arrows. Usually we don't put, but in practical always the length of the arrow always equals to the magnitude of the vector. I'll explain what it means. Length of the arrow. Suppose this has 5 units, suppose. Then 10 units will be like double of that. If you have, like example, if you are bigger than that, it would be 15 units. The length of the arrow always represents the value of the vector. But definitely if you have something 1000 units, you cannot sit on the paper and write like a big arrow from here to here to represent 1000. Okay, so practically we don't write it on the notebook, but actually it means that length of the arrow is always equals to magnitude of the vector. So this is about the representation. Any doubts in this you can ask. Basic thing, this is always the tail, this is always the head. Always to represent a vector we have to put the vector symbol like this, and the length of the arrow is always equals to the value. Magnitude means I told you always the value of the vector. So whenever I say 4 units south, so this is the magnitude, 4 units, and this is always the direction. So this is a vector. Magnitude is only the value, and direction is for this representation. Now from here the main thing, the types of vectors. So there are various types of vectors. Simple ones there. First one is equal vectors. When two vectors are called equal, are said to be equal when they have same value, same magnitude, and same direction. Both are important. Huh? Same magnitude should be also there, and same direction should also be. Example, suppose if I give you, this is suppose A bar, this is suppose B bar. If this is also 5 meters per second, this fellow is also going at 5 meters per second. Then it is, and they're both going in the same direction. See. Then If one of them were going this side, no, like this, and one was going something like this, even though they had 5 meters per second, 5 meters per second, they would not be equal, because magnitude is same, but direction is not the same. They are going in different directions. Then they would be unequal, which will come to know in the next one. So the condition for equal is both should be equal. So obviously, if you have understood equal, then you know what is unequal. Either the magnitude is different, or direction is different. Which does not have same magnitude or direction. Give you example. They have same direction, but different values. Suppose this is 5 meters per second. This is 10 meters per second. Although they have same direction, but they have different magnitude. So A is not equals to B. Another example. This one is 5 meters per second. This one is also 5 meters per second. But A bar is not equals to B. Here what is happening? Same direction, but different magnitude. Here same magnitude, but different direction. And one more case could be what? Direction is also not matching, and magnitude is also not matching. Even in that case, they are called unequal vectors. Then the third type are, write that first. Parallel vectors. Parallel not have to be necessarily be equal. Huh? Okay, parallel can be like any magnitude as long as they are going in the same direction. So the condition for parallel vectors is vectors having same direction. It could be this way, it could be smaller one, could be bigger one, anything. All these are parallel. So A, B, C, D. All these vectors are parallel to each other. So you have to make sure all heads are in one direction. Head should be there all this side. Even if one of them is like this ulta, then it will become anti-parallel, which we'll see in the next case. So the condition for parallel is they should all follow the same direction. Means wherever the head is going. Anybody can tell me what is always the angle between any two parallel lines? Can anyone tell me? Angle between two parallel lines, what it is? this between this it is 90 degree, but if they are parallel, can anyone tell me? Just guess what it would be. How much would be theta between any two parallel vectors? Just answer. It could be right, it could be wrong, doesn't matter.
0.
Yes, very good. It is 0. Because see, even if you keep a protractor here and protractor here, the angle is always same. Okay, the angle between any two this parallel vectors always 0. It's like overlapping. The protractor, this if you are keeping, will never change. It will be on the 0 line only. Even if you keep here, it will be on the 0 line only. The angle between any two parallel vectors is always 0, even if they are in the same line also. Next part will be then anti-parallel. Anti-parallel vectors definitely opposite direction. So these are called anti-parallel vectors. And try to bring them together and see, suppose if we had joined them, like this fellow is going this side and this one is going this side. So what is the angle between them? Always 0. Sorry, always 180 degree. Remember, angle for anti-parallel vectors is always 180 degree because they are going in the opposite direction. Opposite arrows will always have 180 angle between them. Next are collinear vectors. Collinear vectors are the vectors which fall in the same line. Or could be other side also, whichever way, but they are in the same line. Here theta will be 0. If they are in the same direction, always theta is 0. Okay, it's like just overlap them and see. Finally, there is no angle between this. So it is always, imagine if they are like if they clash with each other. You are drawing the same arrow on this line, then between them there is no angle only. If suppose it was slightly up, then it would be theta equals to 1 degree, 10 degree like that. But they are overlapping each other. So it will be 0. And in this case, it would be 180. Opposite direction always 180, same direction always 0. So collinear is what? They lie in the straight line. Here they are parallel, but here they are collinear. Next is coplanar vectors. They all lie in the same plane. Means all the vectors like on one of your wall. or everything on the ground like that. They're all in the same plane, suppose. Doesn't matter where it is starting from, which side it is going, not necessary it has to be parallel or something. They just have to be on the same wall. If suppose like on this, one arrow is here, one is on the floor, one is here, somewhere here, then these are called non-coplanar. But everyone is there in the same wall, then it would be coplanar. So what it means is two or three or more vectors falling in the same plane. So those are called as coplanar vectors. Seven type are concurrent vectors. Concurrent means vectors acting at the same point. One common point, okay? So they will have one common point. Suppose if you have like this is the common point. One fellow is going this side. Suppose one fellow is going this side. F1, F2. So all these three forces are there. But finally, they are from the same common point. It's like originating from one single point. The body of whichever the force is acting upon from that remains the same. So then they are called as concurrent vectors. Suppose if you have like a wall and you have a string, suppose a thread, and you are attaching some weight to it, suppose a block you have tied. So what is going to happen? At this point, all the forces will act. So it's like F1 to this F2 and F3. Because the string is trying to keep it holding, it is not letting it fall. There will be force which will be pulling it this side also, and this block is trying to pull the thread down, and this whatever you are keeping it fixed is trying to keep it upwards. So like a concurrent force from here. This is a normal real life example of concurrent forces of concurrent vectors. Next is a zero vector. Obviously, zero vector by the name itself, you know that magnitude is zero and has no direction. Or you can say has any arbitrary direction. At the moment where vector is zero, direction will not matter which direction it is going. The value itself of that vector is zero, so it will not exist like this. Then the value is zero means as per the magnitude, the vector becomes zero. Any random direction it could be, it doesn't matter to us as long as the value is zero. The basic thing, zero vector has magnitude zero. Next one is a unit vector. value of unit. Unit means always 1, you know that. From the word itself, unit means always 1. 1 unit. Okay, unit. So magnitude is 1. Value of that vector is always 1, then it is called as a unit vector. Suppose if is unit vector, then what is this symbol I told you? Whenever you put like a modulus sign, it always means magnitude. Whenever you want to represent magnitude, just put modulus sign like this. And usually indicated by, whenever you have like this, it is also equal to, you can put like this also, a cap. The arrow becomes like a cap for unit vector. So when the moment you see this cap on any of the letter, you know that its value is 1. Because only unit vectors will have a cap on their head. And which are the standard unit vectors which we have known? Standard unit vectors. Does anybody remember standard unit vectors? 3 letters I told you. Along x-axis there should be 1 vector, along y-axis and along z-axis. Which are those? Does anybody remember? Something with I cap. I cap is along which axis? These are the standard unit vectors which I've already told you in the previous chapter. So I is along which axis? Tell fast. As per the letters only the order is. Which comes first?
X.
H. So I is always along the x-axis. Y is the J is always along y-axis and K is always along z-axis. So these were the types of vectors. Next topic is parallel shifting of the vectors. Suppose if I have an example, give you one vector is given to you like this. This is a bar. I can always change this fellow's position from here to anywhere, but anywhere means not randomly. It has to be parallel shift only. Means I don't want that vector to be here. I want to shift it somewhere else. I can always shift. Its value or its meaning will never change. So what you have to do, you have to only shift it parallel. So I'm shifting. Okay. Why I'm not doing here only? Because when you're studying, you will not know what was given and what was shifted. So that's why this was given and now I'm trying to shift this vector. So what I'm going to do, I'm just parallelly shifting it and putting it back here. So here from here, I'm putting it here. So I'll just put arrow here. So now it came over here. You can always shift it. Now the value of this one will never change. The direction is also this side only and its value also is that only. Same angle it is. If this is 60°, suppose if this was 60°, I'm not doing anything. This is also at 60° only. So I can always shift any vector parallelly. I cannot do like this. Then its meaning will change. Direction also will change. So what is parallel shifting of vectors? So moving one vector parallelly to another place. But what you have to make sure is that body which is acting on, it should be on the same body. Suddenly, if this was here, it was acting here, then the body should be here. Okay, simply you cannot shift and put it somewhere in the air. So whatever the force is acting upon, that should be on the same body. The condition is force or that vector otherwise there's no point shifting the arrow. If he was acting on this body and then you have shifted it for no reason, okay, and then it is acting on nothing, it doesn't have any meaning. So that body also has to be there, shifted, then it will have the same value and same meaning. You can always shift any vector provided you are shifting it parallelly. So if this was, suppose force was 10 Newton, this also will be 10 Newton. If this was given to me as 10 Newton, even after shifting, it will remain as 10 Newton only. So this is parallel shifting of vectors. Next is angle between two vectors. So while calculating the angle, you have to be very careful. There's a rule. You have to always measure the angle with respect to tail, or it should be head to head. Otherwise, what you have to do? Parallel shifting. Whenever I want to measure the angle, if tail to tail directly is given, I can directly measure that angle. Head to head is also given, I can directly measure that angle. But if head and tail is joining each other, then I have to do some parallel shifting and bring tail to tail together or head to head and then measure. I'll give you an example. First one, suppose this is A and this is B. Now you see, I can, this is following what? This condition. So here what is happening? I can measure tail to tail is connected. So therefore, directly you can write theta is 90 degree. So angle between A and B, angle between the two vectors is 90 degree over here. Why? Because both the tails are together. Now even in this case, so what is happening here? Head to head. This is 30 degree. Therefore, directly theta is 30 degree between the two vectors. So this is second case. Suppose if you have third, And suppose this angle has been given to. One second. Now, can I say the angle is 120 degree between A bar and B bar? No. Okay. Here what is happening? This is head and tail combination. Either it has to be tail and tail or head to tail. This is head or tail. So cannot take 120 degree. So theta is not equals to 120. I cannot say, otherwise it will be wrong. If you say angle between A bar and B bar is 120, then it will be wrong. Just put these arrows. Now what to do? We have to measure the angle between A and B now. So what we'll do is, we'll use the parallel shifting method. Now for this one, we'll try to find the angle. Parallel shifting can also be done, not necessary. It has to be sideways only. It can be in front also. Okay, parallel shifting means obviously this line is in the same direction. As long as I'm not changing the direction of the arrow, see here also I'm not changing the direction, here also I'm not changing the direction. So this is also considered to be parallel shifting only. So what I'll do, I'll take this ahead. I'll shift this B upward. I'm not doing anything, I'm just taking this up. So if it was here, okay, this was given to me, this is 120 degree. I'm taking it up. So this is parallel shifting. I've just taken it ahead. I've not changed the direction at all. And now this is my theta. Now what is happening? Now it is tail to tail. I hope you all are understanding. If you are not understanding, then please ask. I just have to make sure that tail and tail is coming together. So I'm just shifting the B upwards. I'm not changing the direction of the arrow. It's the same thing. I'm just extending it up. This fellow I've shifted here. Now theta. Can anyone tell me what is this value? Total angle should be how much? This full angle of a line, any straight line will be how much?
180.
Yes. So 120 plus theta is 180 degrees. So theta will be obviously 60 degrees. The angle between A bar and B bar is 60 degree, not 120. One more way also you could do, huh? Or you could shift A this side. If this was given to me, I'm just shifting this fellow behind. Direction is anyways the same. A, I've shifted. This was 120 degree. Now this will be theta. I want to find what is the angle between A and B. Here now head to head became. The same thing. Theta plus 120 will give me 180. So theta will be 60 degrees. Both the cases, whichever vector you want to shift, you can shift. And then you'll get angle same. If you have done this, so this fourth one, and tell me what is the angle between A bar and B bar. Tell me what is theta. This is A bar, this is B bar. So either you bring this fellow behind or take this fellow in front.
30.
Yes, it will be 30 degrees. So whichever way you want to take. So if you shift this fellow behind, this is 150. I'm shifting this fellow behind. I'm shifting A behind. So this is theta. So definitely theta plus 150 will give me 180 degree. Now it's head to head, so I can always calculate the angle between A bar and B bar. So theta will be 180 minus 50, which is 30 degree. Or if you shift B upwards also, you'll get the same thing. You have that this 180 degree line will become. So this is how you have to calculate the angle between any two vectors. Next question. This is A bar. I'll draw this first. B bar. This is C bar. This is D bar. I just want to draw in the same, this point line you draw, okay? Exactly in this point line you draw this A bar. Make sure it is reaching here at this point. This is A bar, D bar, A bar, A bar. Calculate angles between A bar and A bar, A bar and between each and this B bar and C bar, all the angles, okay? All vectors, okay? Now this is at the side, so I want to check all the angles. Okay, so what I'll do, I'll shift this over here. I'll bring him close to this one. So either I can keep like this after shifting. I'm bringing it here now. Yeah, I brought here. But this is wrong. Why? I cannot keep like this. What is going to happen? I cannot measure these angles then. This will be head and this will be tail. So best option is to take it in front. So I've brought it here and then after shifting, I'll get it here. So this is A. I have not done anything. I just shifted it there so that all the tails are coming together. I've shifted. Now looking at this only, you know, this is how much? 90 degree. B is a perpendicular line. This is also 90 degree then. Okay, so we got the angle between A bar and this. And this is given, you can write otherwise. 30 degree and this fellow is given as 60 degree. In the question, this fellow is given. This is 60 degree, this is 30 degree. So here you know this is 60 and this is 30. Find this angle. Can anyone calculate and tell me this angle?
90.
Yes, it will be 90 because 60 plus theta plus 30 will give me 180. Total should be 180 because they are all on the opposite side. Therefore, theta will be 180 minus 90. That will be 90 degrees. Now, any angle, any vectors you can tell now. So, between A bar and B bar, it is what? It is 90 degree. Then A bar and C bar, it is 30 degree. Now, between A bar and D bar, so that will be total 30 plus 90. Same way you can calculate between B bar and D bar also, whichever one, any angle if they ask, you know how to find this between any two vectors, you can always calculate. Now between B bar and D bar, if it was a 60 plus 90, that would be 150. One more thing I'll tell you, the angle should always be between 0 and 180 degree. It means take the smaller angle. Take the smaller angle. It means what? Suppose if I want to calculate between A and C, somebody asks me what is the angle between A and C. There are two options. Either you can tell me this is 30 degree, or you could take a full round and come back and say it is what? 360 minus 30. So if you have anything like this, you have to always take the smaller angle. If you have two vectors like this, if this is 30, obviously this is 330 degree because total should give me 60. So you have two options to write. The angle between A and C is what? 30 or this. So theta always you have to take 30 degree because always the angle has to be less than 180. You have to always take the smaller angle. Any doubts in this? You can ask. Next one is addition of vectors. So first method is head tail method. So for head tail method, what you have to do is we will always have something called as resultant. To find resultant are join the first vector tail with the last vector's head, the head of the last vector. It means example, suppose if I have a person goes 3 meter east, and then 4 meters north. Calculate R. What is the resultant vector? Means the shortest distance between the first and the last. It's like a displacement. Distance would be normal 7 meters. He is going 3 meters east and then he is going 4 meters north. Distance covered is definitely how much he has walked. He has walked 7 meters. But we are talking about vectors, so we don't want distance, we want displacement. And you know that what is displacement? It is nothing but the shortest distance between your starting point and the ending point. So this is like the long cut method. That is for your distance without any displacement would be this. That's nothing but called as a R, the shortest distance from here to here. How to find the resultant? I told you, join the tail of the first vector to the head of the last vector. So tail to head, we have to just join. That's a resultant. This is a, how to calculate this? Obviously, over here you can use
Pythagoras theorem.
yes, Pythagoras. So whenever you have a 90 degree, that time you can always use this head tail method. Later we'll see when there's no this 90 degree, you cannot use Pythagoras. Then you have to go for the next type of method that will be called as parallelogram method. This will be, so here you can directly calculate. R will be square root of always the side squares. 4 square plus 3, that will be 16 plus 9, so root of 25, which is 5. That would be 5 meters. So displacement is 5 meters and distance would be 7 meters. Now in the next case, another example. And not to calculate, just to show you, if this fellow is going here first, A to B, then B to C is coming here, and then over here. Now I want to calculate the shortest distance for the displacement. So as per the definition, what will be the resultant vector? Join the first fellow's tail to the head of the last one. So this would be a R. So displacement is nothing but A to D, where A is your tail and D is your head. Starting fellow will always have a tail and then ending fellow will always have a head. Calculate the displacement here. A to B is 4, B to C is 3 meters. Again is going this side for 4 meters. This is again 3 meters. So we have to calculate the displacement. Draw it again because you will not know what was the question given and what you have to find. This was the question. You have to find displacement. Now start doing your calculations. So obviously it will be like this. A to C2. R, you know that you can put this as R1 and this fellow you can put as R2. So you have two triangles. First calculate your R1, then calculate your R2. In this case you will get same because 4 and 3 only are there, the same numbers. Still will calculate. So R will be R1 plus R2. This length plus this length. So R1 is what? This is the hypotenuse of this triangle. So 4 square plus 3 square plus 16 plus 9 root of 25, which is 5 meters. So this fellow is 5 meters. Same way you can calculate your R2. If they were different numbers, you have to put different ones. So here it is 4 square again plus 3 square. You can just directly do it 2 times also because you know that they are same numbers. So this also you will get as 16 plus 9. So that will be 5. So total R is how much? 5 plus 5, which is 10 meters. Any doubts in calculating the resultant when an angle is 90 degree? You can ask. Now let us see in vectors whether addition is commutative. Before that, one more problem will take. The person is going 3 meters west, 3 meters north, and 3 meters east. Shall find displacement or find a resultant, whichever way you want to see. So start at one point, then go towards west, then go towards north, then go towards east. We are starting here, suppose we are going towards west. Obviously, everyone knows north, south, east, and west. So west is this side. So 3 meters is going, then 3 meters is going towards north, then again is going towards east. And now you have to calculate the displacement. Now don't join like this. It's always between the first and the last one. So this is the first vector tail and this is the last vector head that you have to join. This is your R or the displacement. Now can anyone tell me directly looking at the diagram itself? There's no need of calculations here. How much will it be? How much will be the distance? If I'm naming this as A, B, C. So what is the, from here to here, what is the length of AD? Look at the diagram and tell me quickly. All the sides are 3 meters.
3.
Yes, because it's a square, no? See, this is 3, this is 3, this is 3. It's a parallel line. So obviously any parallel line if you have, these are all 90 degrees. So angle anyway is the square. So even if it was something 6, if you had something, this was 3, this was 3, and this was 6, definitely opposite parallel or lines are always equal. So that would be same as this. So AD is same as CB. which is equal to 3. So therefore r is 3 meters. If direction is asked, if you want, it's always towards north. This is important. Displacement is 3 meters. Now we'll check whether it is commutative or not. We know we'll prove it. Vector addition is commutative. Commutative means always A plus B is same as B plus C. Now we'll check. This is the main thing given. So your left hand side is what? A plus B. So let the angle be like this. Randomly we'll take. If this is A and if this is B, your resultant is, you know, that R is going from here to here. This is any example you have to take for the left hand side. A and B. So A bar plus B bar is always equals to your R bar. This is your resultant vector. So remember, R bar is always equals to your A bar plus B bar. In terms of vectors, when you want to calculate this, there we could use Pythagoras because that was 90-degree normal. But in terms of vectors, if you want to know, always the vector addition says the resultant is always equals to A bar plus B bar in terms of vectors. I'm not directly talking about values. If this is 3 meters, this is 4 meters, you cannot say R is 3 plus 4, which is 7. That is wrong. These are values, magnitudes. And these are just the directions. A bar and this resultant is this. So we'll check whether it's same as B bar plus A bar. So what we'll do is we'll do parallel shifting. So right now it is here like this. And this is my resultant. So I'll just parallel shift this fellow up. Or I'll parallel shift this fellow this side. So what is going to happen? This will be my B bar. So I've parallel shifted this fellow at the side. The straight line. I'm shifting B bar this side. Same way I'm shifting A bar up. So we'll get a parallelogram. Exactly parallel shifting I have to do. So this becomes my A bar and this becomes my B bar. Now check B bar plus A bar. This fellow is the starting point now. And this fellow is the ending point. So where is your resultant? It's the same R. B bar plus A bar is also equals to R. So therefore, A bar plus B bar is same as B bar plus B bar. So even if you shift, so while reading this one, how you were reading, this was coming first vector. And this was coming second. A bar plus B bar was equals to R bar. Now over here, after parallel shifting, B bar came first. So B bar plus A bar. So this is your first vector, this is your second vector. But even if you join the tail of the first to the head of the last, that R is remaining same. Nowhere it is changing in both the cases. That R is remaining same. So B bar plus A bar also you do, or A bar plus B bar, it remains same. So therefore, whether you add first to the second or second to first, resultant will remain the same. So that's why it is called commutative. Commutative means both the ways you can put. A plus B same as B plus C. Now in the previous cases we had calculated resultant. It was easy using Pythagoras theorem because angle was 90 degree. Now suppose if you have a different angle only. In this case what we could do straight away, we could find R by finding R A square plus B square. This was easy. But suppose if you have like this. In this case you cannot draw a hypotenuse now because the angle is not 90 degree. Okay. In that case we have to use parallelogram law. So whenever angle between two vectors is not equal to 90 degree, we cannot use head tail method or tail head method. That's why we have to use the second method, that is called as parallelogram law or parallelogram method. So what we have to do is to just draw one diagram and derive, in this case, how to calculate the resultant. Okay. So you have to, what you have to do is, there are some steps. First you have to do is join the two vectors. Join two vectors. Just write this and keep. Once you are solving, you'll understand what it means. Join the two vectors from tail to tail. As two adjacent sides of the parallelogram. Then next step, complete the imaginary pattern or imaginary parallelogram. Then calculate resultant. Here, while calculating resultant, we cannot use Pythagoras method. I told you because the angle will not be equals to 90. So what is the formula for the resultant? I'll just give first and then we will derive. So if I have this, I'll just give you the rough diagram and then we'll use for the proof. So if you have A bar and B bar, now this angle is not equals to 90. So what I'm going to do is, I'll use the parallel shift. I'll complete the parallelogram. So this fellow's parallel is like this. And this one's parallel is like this. So join both. Okay. So join the two vectors from tail to tail as two adjacent sides of the parallelogram. So these are two adjacent sides of the parallelogram. Then complete the parallelogram. So we have to complete this. So this fellow is a bar, same direction. So this head will be here, and this one will be here. And now what will be your resultant? Resultant is always equals to diagonal. This one will always be a resultant. So the first step says the two vectors A and B should be having tail to tail joint. Okay, the two adjacent sides of the parallelogram. If not, if they are separate, bring them together in this form. Okay, like this. Then complete the parallelogram, imaginary parallelogram, this fellow, and then the diagonal will always be your resultant. So the resultant formula is this, you have to by heart. R square will be equals to a square plus b square. This is not a Pythagoras theorem. This is a different one. 2ab cos where theta. These are all the magnitudes. Okay. These are the values, and theta is the angle between. This is also magnitude. R is also magnitude. Some teachers will give you R as root of this, R square, or you can also write it as root of square. If you remove, root will go here. So whichever formula, it means the same. Either you can write this or this. Now, this resultant is the magnitude. Suppose if I want direction of the this, which side, which, okay, or the in terms of angles. See, this will give me the value of the resultant. How much distance is here? Suppose if I want to know what is the angle, okay, what is the angle of the resultant, then we have to calculate. So the formula for that is, suppose if you are taking that angle as alpha, this is anyways theta. Angle between a bar and b bar is theta. Now we cannot take the same theta here. Okay, I want to know what is the angle of the resultant. So that will take it as alpha. So tan alpha is b sin theta upon a plus b cos theta. We'll derive this formula. As of now, to study, we write and give. For problems point of view, you have to by heart this. So this is magnitude of resultant. This fellow is direction of result. So if you are asked to calculate only the magnitude, you just have to stop here. But if you are asked, like suppose force, force is what? Force is a vector quantity, I told you. Anytime you have to calculate force, you have to write the magnitude as well as this direction. So problems involving force problems, no? Force of 1 Newton is applied and all. In that case, you have to calculate both magnitude as well as the direction. So we'll start with the derivation. This is the proof. So we'll draw the diagram first. This is your A bar. This is your B bar. Now complete the parallelogram first. Now we'll name them. We'll consider this M, N, O, and P. We'll name the parallelogram as M, N, O, P. Now this definitely is a resultant. This is the angle theta. Okay. What we have to do, this we have anyway seen in the previous one also, same diagram we have drawn again. Only what extra we have written is this. M and OP we have written extra. So your first step is draw a line perpendicular from point O to line MP. Or you can also say, if you want to know in short words, like draw a line OQ perpendicular to PQ. Means what? You just have to extend this and name it as Q. We can draw a line OQ which is perpendicular to PQ. So this is the main condition. You just extend this line, mark it as Q. So definitely OQ is perpendicular to PQ. Now, if you notice, this angle will be theta. This and this. See, angle NMP, NMP is same as OPQ. Why? Always remember that. If this is 60 degree, this also will always be 60 degree. Why? They are always corresponding angles. We have already studied this in 10th standard. That way both will be equals to theta. So if this is 30, this also will be 30 because they are the same parallel lines. So even if you keep a protractor here or here, it will give you 60 only. It will not change. They are called as the corresponding angle. So this is theta means this fellow also will be theta. Now in triangle, now we got a new triangle. See. OPQ, OPQ. What is cos theta? Cos theta is what? In terms of always we have studied, it's always adjacent upon hypotenuse. Everyone should know this. Cos theta is always equals to adjacent upon hypotenuse. Sin theta is what? Always opposite upon hypotenuse. So let us see. I want to find cos theta in this triangle. So which is the side opposite to this angle? We have to check adjacent because adjacent upon hypotenuse. No, so check for the adjacent side. So it is PQ, and then which is the hypotenuse? OP or PO, whichever way you want to write. OP or PO. If this is B bar, you know that this is also B bar. This is also A bar. So if this is 7, this will also be 7. If this is 10 units, this also will be 10 units. So what we got? Cos theta is equal to PQ. What is nothing but OP? OP is nothing but B. Value of your B. OP is nothing but B. So therefore, what you'll get? B you take this side. B cos theta will be equals to PQ. Put this at 1. Equation 1. I got the value of PQ. B I just took up. Now in the same triangle, okay, what is sin theta we will calculate. Sin theta is always opposite upon hypotenuse. So which is the opposite sign? OQ upon hypotenuse is what? OP. Again, you know that sin theta is OP is nothing but B. So B you bring up, you'll get a value of OQ. Put this as equation 2. What you have to do? Take this triangle, find what is cos theta, then find what is sin theta. Opposite upon hypotenuse. Only here you have to remember, put the value of this line as B, because this is same. If this is 10, I told you this will also be 10. Now you have to find this resultant. Our aim is what? To find the value of this R. R is hypotenuse of which triangle? If you see, now we have to always look out for the 90-degree triangle always, because it becomes easier to check. Resultant is nothing but a hypotenuse of this right angle triangle. So in right angle triangle, which is that MOQ. MOQ. So who is the hypotenuse? MO square is equals to, the hypotenuse is always equals to the side square. So this is one side, MQ square plus OQ square. So check in the big right angle triangle, R is nothing but the hypotenuse. So MO square is equals to MQ square plus OQ square. Now what is this? MQ is nothing but a part, it is in two parts. See, MP plus PQ. So MQ can be written as MP plus PQ. This is OQ square only. This is only one line, but this MQ was part of two lines. The addition of two parts, MP and PQ. What is the value of MP? MP is nothing but A. If this is 20 units, this value, we would have to write it as 20 that way. So M to P is nothing but A. Don't have to put vectors, because we are calculating the normal value now. We are calculating the magnitude. So we have to take normal A. PQ is how much? Nothing but from equation 1. What is the value of PQ? B cos theta. And what is the value of OQ? B sin theta. From 1, I got this, and this I got from 2. And now let us expand this. We'll use the formula A plus B the whole square. So this is A square plus 2AB, A into B, 2AB, then B square. B square means the whole thing. This whole thing is like B. This is your first term, this is your second term. Then this square will belong to both the terms. So B square and this will be sine square theta. Square will belong here also, square will belong here also. Now open up this brackets. So a square plus ab cos theta. Now square will belong to both the terms. Now a square plus 2ab cos theta plus b square. What is common between these two terms? B square is common. We will get cos square theta plus sine square theta. Now, under math, this not there will be a trigonometry chapter. Normally, they used to keep it always first in the first exam. Now, this year they have kept it later on. Actually, that should have been done first as per the Goa board, but now they have not kept trigonometry chapter. Under that, you will come across this formula. Will prove it. Math students will come to know in the next term. Now, after this exam, now whichever, we'll have this trigonometry chapter. So remember, now you have to just know it because that chapter is still not done. And physics, anyways, students those who have dropped math have to know it. So sine square theta plus cos square theta is always equals to 1. This value. Later we will come to know.
So in 10th we have that.
Are you all had? Okay. Thank you. So sine square theta plus cos square theta will always be equals to 1. So straight away put that as 1. This side was what? MO square. MO is nothing but you can put it as R. It was the diagonal, no? MO was your R. Cos theta. This is 1. So answer is same thing. I'm just writing b square first. So this is the formula which we had written for the resultant and which you have to know it by heart also. For if the angle is 90 degrees, then it is only this much. R is root of a square plus b square. But if the angle is not 90, then you have to know this formula. Now for the direction, we'll see. I told you. So I want this. You just put alpha in your main diagram. Don't need to draw it again. The main one which I erased, no? Just put this much as alpha. So which angle we'll see in the same triangle? In triangle MOQ, we'll take tan alpha now. Tan alpha is nothing but, instead of theta it is alpha, but this remains the same, opposite upon adjacent. Tan theta is always nothing but opposite upon adjacent, which is the opposite sign. Opposite side of the angle is OQ, and which is the adjacent side MQ. So tan alpha is nothing but OQ, we'll keep it that only. MQ is again I told you of two parts, M to P and P to Q. Now substitute the values. OQ is nothing but your equation number 2. From 2, value of MP, we know that it is nothing but A. From here to here it is A. And then PQ is from equation 1, B cos theta. So this is how we have proved. You have a question now? A man walks 5 meters east and 6 meters at 60 degrees from east. So from there on, then he goes at 60 degrees from east. Calculate magnitude of the resultant. Or magnitude of the displacement. Only the magnitude part, we don't want the angle part, okay? Now what it means is, a man is going 5 meters here, and then from here he's going towards east, and then from east he takes a 60-degree angle from the east. Once he reaches towards the east, he takes a 60-degree angle. We can name it as B. This will be A. Now we have to calculate what is this resultant. But directly we cannot start this now. Why? Because as per the first rule, what should be there? Tail and tail should be there as your adjacent side. Now this is what the head is with the tail of the this. So first we have to do parallel shifting, bring B this side so that it is the proper adjacent sides of the parallelogram. So as per the first step, now this is a question. So we have to do parallel shifting of B. So your solution starts from here. Don't do it here only. This was a 5 meter. Now I'm shifting B this side. I'm not changing the angle, 60 only I'm keeping. This is my B. So now tail and tail are the adjacent sides of a parallelogram. Now step number 2, complete the parallelogram with the imaginary line. You have to draw a line parallel to B. You have to draw a line parallel to A. Wherever they meet, put the arrows like this. So this is your result. So now we have to calculate just the value of R. And you know that now angle is not 90 degrees, so you cannot use Pythagoras theorem. So now you know that formula is there, R. R square is what? A square plus B square. So use this formula to calculate the value of R. B is given to me as how much? 6 meters, no? R square will be nothing but 5 square. This is 6 square. 5. B value is 6. Now cos theta. Theta is always the angle between the A bar and B bar. So this will be cos 60 degree. Now calculate. So this will be 25. This will be 36. So 2 5s are 10. 60. Cos of 60 degree is 1 by 2. You should know the trigonometric values. Whether you're a math student or a physics, doesn't matter. The trigonometric values you have to know. So it will become 30 then. have to calculate it. So 25, so that will be 66 plus 25. That would be 91. So it will be approximately 9.5. So this will be a resultant. Next question. What is the time? Question is two forces of magnitude 6 Newton each act at a point as shown. Find the resultant.
Teacher, how to find that final answer? Root 91.
This one, long method. You all don't know how to find square root using long method.
Okay, okay.
Normal method, or else using log tables. Log tables have been taught to you all. I need to take one separate class for that. But right now, since this, what is that? Students are starting from Monday the exams. That's why I'm not doing. After that, whenever I have time, no, once I finish this chapter, I'll teach all both the methods using log also and this. Now you'll manage. Mostly it will be online class, no? So you can manage directly finding the square root. Otherwise afterwards I'll teach. Otherwise normal method which I'll have studied. Take any of this. The closest square, 9 9s are 81. This almost have already studied. Then you have to take 10. Then closest value. You have to add this 9 to 9. Then that would be 18. Then add zeros and then check. I'll teach you that method. As of now, you already know, then use. Not know, then use timing calculators. Then I'll teach you because it will take at least one class using logs and so two forces they act on a point as shown in the this. So find the resultant. So this will be figure is given to you all. This 60 degree and this is 6 Newton. This is 6 Newton. We'll take it as A bar. We'll take it as B bar. So angle is 60. So definitely if you extend this, or you have to calculate. Now whenever this forces come, no, you have to calculate magnitude and direction. No? So you have to calculate R also as well as alpha also. We'll have to calculate this also and R also. So as per the formula normal, this is the formula which we know to calculate the magnitude. This is simple. Straight away put all the values. 6 square, B is 6 square, A is 6, B is 6, and cos of 60 degree. So just now I told you cos 60 is always 1 by 2. 36, 36, 36, 72. again 36. You know 36 is a what proper root. Okay. Some of the teachers, no, they ask you to keep in terms of root. So if your teacher is asking, then you can keep that much only. So this r square is 3 times 36. You can do like this also. Or you can use the long method, the 72 then plus 36. But you know 36 is a perfect square. So while taking square root, it will be easy. So just see now, r will be square root of 3 into 36. So this will anyways be root 3 and square root of 36 will be 6. The answer will be 6 root 3. You can do it this way. So this is your magnitude. Now we have to calculate the direction. Direction formula I told you. Tan alpha b sin theta upon a plus b cos. Now put the values. B is 6. Angle will remain same. 60 degree. A is also 6. B is also 6. Cos 60. Sin 60 is what? Root 3 upon 2. So this will cancel. This will become 3 upon 6 plus 3 will give me 9. If nothing is there, it's like 1. So if you reverse it, it will become like this. 1 by 9. And then 2 and 2 will cancel. So root 3 upon 3 is the answer. In the first class itself, when I was doing the basics of mathematics, I've taught you. Anytime you come across the same number but with a different root signs, you can always write a bigger number. Out of this, this is a fat number or the big number, you can say. So you have to split him into root 3 and root 3 because root 3 into root 3 is always 3. And then you have to cancel. So what answer you are getting? Tan alpha is nothing but 1 by root 3. Tan of which angle is giving me 1 by root 3? I have to think from the trigonometric table. So tan of 30 degree. If you can go back and check in a table, or you should know tan 30 is always 1 by root 3. So what is your value of alpha? Alpha is always 30 degree. So your direction is, the resultant is having 30 degree. So you got the direction, you got the magnitude for the force. So remember, anytime if any two vectors are same, no? See, in this case, what was happening? A was also 6 and B was also 6. So it's a shortcut. Suppose if you are solving any MCQ questions and all, no, objective types, you cannot waste so much time in calculating this. So suppose if you have two vectors, so remember this as a note. Two vectors are same, no? Suppose value of A also, B also is equals to X, suppose. Here it was 6. Now let it be X. Then your answer. Resultant will always be equals to how much I had got if this was 6. See, when this was 6, resultant you got as 6 root 3. The answer will always be equals to x root 3. An angle will be fixed always equal. Here an angle should be equals to 60 degree. This is also compulsory. And alpha will always be equals to 30. So this is a shortcut formula, like instead of doing all this, if it's a tick mark question, no one will ask you what you have solved. They just want the answer. So in that case, if two vectors are same, then answer straight away that what value root 3. An angle will always be fixed 30 degree. Okay, so I'll stop here. Next class, let's solve some more problems based on this, and then a new topic, resolution. Take attendance. Okay, those are finished, and